There's one thing that is different about the stuff that we're doing now compared to the last. Oh shoot! Compared to the last unit, some of the questions are going to look very similar, but they are different in an important way. So that's, I think, part of what you want to figure out in this over the next 2 days kind of thing, is how they're different. But then it does help to recognize that parts of them are the same as well. That, I think, would be helpful. Like a question like this is one that's very similar to ones that we've solved already. And let me put my poppy back on. It's this bolded number over here. So let's read this question. It says the sum of two numbers is 24. That part we've seen. The sum of the squares of these two numbers is 289. In the last unit, it would have said max min. So this is not a max or a min. That means we solve these questions in very different ways. As a review, when it says the sum of the squares is a max or is a min, how do we solve it? It was a long time ago. Does anybody remember? Just generally. Yes? That part's not going to change, so that's good. Generally, we'd do the let statements. We'd set up our equation. We would complete the square to put it in graphing form to find the vertex where the max occurs. Sound familiar? From the last unit? That's how we used to do it. When it says the sum of the squares is a maximum, you'd complete the square. When it says the sum of the squares is 289 or some other number, then we're doing it a very different way. We're doing it like this. And we're doing it with like factoring and the quadratic formula like we've done in this unit. Everything we've done is solving by factoring or solving with the quadratic formula. It's all solving. So in this case, I'm going to get an equation to solve. In the other case, I had a function, y equals, or a equals, or s equals, or p equals, whatever you chose. Okay, so that's how they're different. But a bunch of it's the same as well. So we are going to start with let statements. Let x represent one number, and let y represent the other. And it tells us two things. The sum of the two numbers is 24. How do I write that out? Minute. Very nice, very simple, but hugely important. X plus y equals 24. And then what am I going to do? I'm going to move the x over and I'm going to say y equals 24 minus x. That's the part that I need. Then it says the sum of the squares of these two numbers is 289. And I'm going to do it like this. I'm going to start with my two original numbers. What does it mean, sum of the squares? What's the square of a number? If my number's x, what's the square of that? Do you know? No, that's a square root. We want the square, so you're close, but we want to go the other direction. Sarah? Yeah, it's going to be x squared. So the square of x is x squared. I'm squaring it. And the square of y will be y squared. And it says the sum, which means I add them, and it says is 289. The sum of the squares of the two numbers is 289. In the last unit, we would not have had that equals 289 part. That makes the whole difference. We would have had a variable there, equals y or equals s. Now I can replace y with the thing that I did in the last one. So this is x squared plus, what is y again? 24 minus x. And we need that because we need an equation that has only one variable. And then I just solve this thing. To me, that's like, bam, first step. I mean, the first mini step is the let statements and coming up with the y equals 24 minus x. But your first big milestone in this question is getting your equation here done. That was one part. The let statements and all that was working up towards there. Then I go into solving mode. I switch hats and I just think, how do I solve this thing? I don't even have to worry about what x is, what the numbers are, that kind of thing. I just solve. How do you think we're going to solve this? Can anybody describe how we might solve this? Brooke, do you have any ideas? Nice. I call that expanding, simplifying. What else are we going to do?
Move it to 289 to the other side and set it to 0.
And in this case, it's 289, but whatever it was, move everything to the same side and set it equal to 0. Expand the brackets, expand, simplify, move it all to one side, set it equal to 0, and then figure out what we have and figure out how we're going to solve it. Very nice. And this, I'm going to do this the long way. You wouldn't have to, but some of you will like to. Whoops. Right? 24 minus x squared is not, oh my gosh, not this. 24 minus x all squared is not 24 squared minus x squared. That's what some people would do. That is never how you do it. Never ever do that. You don't square the first term and square the second term. It's two brackets multiplied out. So 24 times 24 is 576. Then minus 24x minus 24x. Negative x times negative x is plus x squared. I can move the 289 over. Minus 289 equals 0. X squared and x squared is 2x squared. Negative 24 is negative 48x. 576 minus 289 is 287. Again, remember when I said it's so important that expanding and simplifying happens correctly. Like, obviously, you're going to try to do it right. So me telling you, make sure you do that right. Well, you're always going to try to do things right. But I'm just saying, like, don't rush through that. Like, take your time as much as you can and be careful. Use a calculator if you have to, because getting to that step correctly is going to be really important towards the rest. The rest you probably will get right if you get to that step right, I think. What do we do now?
Use a discriminant.
Very nice. What are we looking for, Zach?
See if it's factorable.
To see how we're going to solve this thing. We got to solve this thing. It's not max or min. We're solving it. So b squared minus 4ac. And I happen to know that it is 8. You can confirm that if you want, but I believe it's 8. 8 is not a perfect square. So we're going to use the quadratic formula. And in these word problems, I'm going to allow you to skip writing out the formula every single time. You still should if you're still memorizing it. If you ever get it wrong, you got to keep writing it out. But we can cut to the chase here and just write out what x equals and skip the formula. But I'm going to write it once in case anybody forgets it. Negative b plus or minus the square root of b squared minus 4ac all over 2a, which means x equals negative b, which is positive 48. Negative 48 all squared. Make sure you got brackets around that. It's going to make a difference. Minus 4 times 2 times 287. All over 2 times 2. So that's 48 plus minus the square root of 8 over 4. So x is 48 plus root 8 over 4. X is 48 minus root 8 over 4. Everybody okay? So this is 12.7 and 11.3.
It didn't say how many decimal points, right?
No, it didn't. So we're going to do 1 for this question. When you get that written down, put your pencil down and sit back and think about what we've done. Remember when I said we changed hats and we went into solving mode? We put on our solving hat. So we did it. So like now what? Because this was a word problem. It was asking us a question. And you always have to go back and say like how do I answer that question? Do I have enough information in order to answer the question? What was I looking for in the first place anyway? Was this a revenue question? Was it maximizing, minimizing? Was I finding integers? What was I solving for the dimensions of a shape? Like what was I looking for? Because this part will look the same in all of those kinds of questions. So I'm going to go back up and I'm going to say I was trying to find two numbers and I let x and y represent the numbers. Did I find those numbers? Be careful. I'm looking for x and y. Did I find x and y? No, I found x and x. I've got two x's. Some people would think these are the two numbers. Not necessarily. So we have another step to do. Okay? Does that make sense? It will after we've done a couple more examples. This one's going to be a bit tricky actually, but after we've done a couple more, if you don't already remember, you will, because this is very similar to grade 10. These are not my answers. These are two possible values of x. Sometimes they both work. Sometimes only one works. Okay? So what I need to do is I need to come up and say, I need to do this twice. If x equals 12.7, then y equals 24 minus x, so 24 minus 12.7. Or if x equals 11.3, then y equals 24 minus 11.3. (24 minus 12.7) and then 24 minus 11.3. And this is the confusing part. But after we've done example 2, it might make more sense if you come back and think about it. When I did this, I just got the other number. But that only happens sometimes. That usually doesn't happen, I would say. In some kinds of questions it does. In other kinds of questions it doesn't. So you always have to do this and show this. Okay? If you do one of them and you get the other answer, you can stop and you can say they're both the same because you already know that's going to happen. Or you can do it twice. Sometimes you're going to have to do it twice anyway. It's only a fluke that in this case, these turned out to be the two numbers. You're never allowed to just say, therefore, the numbers are that and that. You've got to show this first, then we can say, therefore, the numbers are 11.3 and 12.7. Any questions on that? I'm going to do a quick little summary here. You've got that written down, hopefully. We did our let statements. It said the sum of two numbers is 24, so we did that and we rearranged so we could express one of the variables in terms of the other. You always do that. That's familiar from the last unit, from grade 10. Hopefully we're used to that by now. Then this is the harder part. The sum of the squares question some people struggle with. You could go back and look at your test and see if you got this one or not. And if you didn't, make sure you focus on it. Maybe this will be a second chance for you. Okay? So x squared plus y squared is 289 because the sum of the squares is 289. I sub in for y. Do all my expanding and simplifying. Got a quadratic. Use the quadratic formula to solve in this case. Could have been factorable. This one wasn't. Got two answers. But they're both for x, and I'm looking for x and y, so I have to take my x, find my y, interpret my solution, write a therefore statement. All right, let's try another one. The base of a triangle is 4 centimeters less than, typo, the height of the triangle. Again, in the last unit, we would have seen a question like this, but it would have said the area of the triangle is a maximum. In this case, the area of the triangle is 13 centimeters squared. It gives us the area. That's how I know it's a question from this unit, solving, because it gives me the area. Find the dimensions of the triangle accurate to 2 decimal places. We're going to start with let statements. Whoops. Let B represent the base, let H represent the height. Then I'm going to start writing down what I know. I find it useful to say, it says the area of the triangle is 13, so I'm going to just write that. A equals 13. If you want to watch, you can watch. It says the base is. So I'm going to write base is. How do I write 4 centimeters less than the height? What is that as an expression? Nice. 4 centimeters less than the height is taking the height and taking away 4 from it. And now I've got an expression already done. This is exactly like how I was doing that part there. But this said the sum is 24, and this one said 4 less than the height. But it's the same principle, same idea. What do you think we do next?
You can bring the B to the other side and get your expression.
But I think this is already done. It says B equals. I think we're good. In some cases, we need to move things around like we did in the last one, but in this case, we don't have to. But that's not. This one's not a sum of squares. You're right. What is it in this case? What's relating the base and the height? What's this question talking about, Ellie? Area of what shape? Triangle. So formula for area of a triangle. Area equals 1/2 base times height, or base times height divided by 2. Both will work in this case. And I've got all my information. Area is 13, so I sub that in. Base is h minus 4. Height is h. You got to make sure you only have one variable. What do we do when we have a fraction in these questions? What did we do before?
Multiply.
To clear the fraction. So what am I going to multiply by? Alexis? What am I going to multiply by to get rid of the fraction? What do you think? 2. So I'm going to multiply by 2 on both sides. So 2 times 13 is going to give me 26. Here, I'll show it. 2 times 13 equals 2 times this whole thing, 1/2 times h minus 4. So these 2's are going to be gone, and I'm going to get 26 equals h times h minus 4. Now what do? Expand, simplify, move everything to one side. H times h is h squared. H times -4 is minus 4h. Move the 26 over. In this case, my discriminant is 120, so again, it's quadratic formula. I'm going to go through this quickly because I know you're good at this, because I just want to get to the last step that's more interesting. Plus or minus the square root of -4 squared minus 4 times 1 times -26. And we get 2 decimal answers. It said 2 decimal places, so I got 2 answers. And then our question is this problem done? What were we trying to find? The dimensions, the base and the height. Did I find the base and the height? No. How do you know I didn't? They both say h equals what else, Sarah? Yeah. And this, to me, this highlights why in the last example we had to go through that hoop. Even though those answers worked out to be our answers, often they don't. Because neither of these is the base. They both say height equals. And this one is negative. Can you have a negative base? You draw me a triangle with a base that's -3.48 centimeters long. I'd like to see it. Sometimes negative numbers are fine, sometimes they're not. Sometimes positive numbers are fine, sometimes they're not. Depends on the question. So this one is inadmissible. Please try to use that word. For now, we won't worry about it too much, but it's important that you don't change that word because people change it to other things, but what you're saying isn't actually right. Inadmissible kind of means something very specific in mathematics. So when you get a negative answer like this, that doesn't make any sense in our question, we say it's inadmissible. Can't have a negative length, in other words. Now I have my height. I got to go find my base. If my height is 7.48, my base is height minus 4. So 7.48 minus 4. So again, in this case, look, it worked out that it's 3.48, which is similar. That doesn't always happen either. Often, but not always. And this was a negative, so it still is no good. You can't just say, oh, I'll just make it positive and that'll be my base. No. Okay, you gotta do it the proper way. Therefore, and it asks for the dimensions, so the base is 3.48 centimeters. The height is 7.48 centimeters. Any questions about that? Think about all these questions. What's the same? What's different? This quadratic formula part in the middle is the same every time. That's where you forget about what the question is about and you just solve. It's the setup that's the hard part. So even if you didn't solve every one of the quadratics when you're doing the practice today, practice setting them up. The problem is without solving, you won't know if you did it right, so you should solve as many as you can. One more example. Slightly different kind. You may not have actually seen one quite like this in grade 10, so it might be a little bit new. I don't want to take too much time up talking about ratios. So there's different ways of solving this, and I'm going to show you the most straightforward and simple. You either have to understand something about ratios to remember it, or just kind of memorize that this is what you do for this kind of a question. Not usually the way I would recommend, but in this case, it's pretty straightforward, and they're all the same once you kind of get it. A ratio of 2 to 5, don't write this down, but means if I have 2 of something, I have 5 of the other. If I have 4 of something, I have 10 of the other. If I have 6 of something, I have 15 of the other. If I have 8 of something, I have 20 of the other. What's happening here? This is what a ratio means, right? Was that too fast? Does that make too fast? Think about what a ratio is. It's not saying I have 2 of something and 5 of the other. It's saying that's the ratio. For every 2 chocolate bars, I got 5 suckers when I went trick-or-treating. That's what it means. For every 2 of these, I have 5 of these. So if I have 6, I have 3 6s because I multiplied by 3. So I multiply that by 3 as well. This is kind of from grade 9. You talk about a little bit of this stuff. That's what ratios mean. So long story short, it means I can do this. For one of the numbers, I'm going to say it's 2 times x. I don't know what x is, but I know that one of the numbers would be 2 times that. So what's my other number going to be? 5x. So if x is 1, it's 2 to 5. If x is 2, it's 4 to 10. If x is 3, it's 6 to 15. If you don't fully understand that, don't worry too much about it. It's like I said, these ratio questions always work out the same. Let 5x represent the other number. So if they're in the ratio of 2 to 5, I've got 2x and 5x. Okay? Then it says, if their sum is added to their product. What does sum mean? Added together. So I'm going to take my 2 things and add them. And it said, if the sum, which is this, is added, so now I'm going to add them, to their product. What does product mean? When you multiply them. The result is 54. The sum of the 2 things plus the product of the 2 things is 54. What are the 2 things? 2x and 5x. Now what do? Expand, simplify, move everything to one side and solve. What's 2x plus 5x? 7x. What's 2x times 5x? This is that mistake that everybody makes in grade 9. The difference between adding x and multiplying x times x. 2x times 5x, but we're better at this by now. Got a lot more practice. Very nice. 10x squared equals 54. So I'm going to write it in the right order. 10x squared plus 7x minus 54 equals 0. B squared minus 4ac equals 2209. I'm going to show you something. We're going to use the quadratic formula for this one. So x equals negative b plus minus the square root of b squared minus 4 times 10, whoops, times negative 54 over 2a. What is the square root of 2209? 47. What does that tell us? It is factorable. If you want, go back and give it a try, but it's a hard one because I got a 10 out front and a 54 on the other side, and there's lots of possibilities. And the numbers are a lot bigger. So it's a bit harder. So in that case, you might just use the quadratic formula. But we want to notice, so then I get x equals negative 7 plus 47 over 20, which is 40 over 20. I think, yep, so that's 2. And x equals negative 7 minus 47 over 20. And what does that work out to? Negative 2.7. That is not rounded. That worked out exact. Try it on your calculator again if you don't believe me. But that worked out perfectly. Because it was factorable, so I actually got an exact answer, not rounded. Good to notice on your calculator. I'm done the solving part, so I'm going to go back up to the question and reread it and see what we're supposed to actually be doing. Two negative numbers are in the ratio of 2 to 5. Find the numbers. So what can I do here? Two negative numbers are in the ratio of 2 to 5. Nick, do you have any ideas on what we could do next?
Do 2x and 5x because the x with 2.
Yeah, very good. So I can take this. Remember what we said. The numbers were 2x and 5x. Well, now I have two possible values for 2. So if I use this one, I'll get 4 and 10. What do we know about that, though? Let's try it. So if x equals 2, 2x equals 2 times 2, which is 4, and 5, whoops, x equals 5 times 2, which is 10. Are we happy with those answers? Ben, no? Why not? It says two negative numbers, and these aren't negative, so this is inadmissible. Very nice. Let's try the other one. If x equals negative 2.7, I get 2x is 2 times negative 2.7, which is negative 5.4, and 5x is 5 times negative 2.7, and that should work out to negative 13.5. So those ones we like. Two negative numbers.